when they do encoding. Okay, so you are allowed to choose mode. These are the modes. Okay, mode one is to predict yourself from the guy down here. Mode 1 is to predict yourself from the guy down here. Mode 2 means you predict yourself from the guy over here. Okay? And likewise, mode 3 is a diagonal prediction. Mode 0 is a diagonal up direction. Okay? So this is, and the way they do prediction is this. Okay? Now you can see, let's take an example. Mode 3. What is mode 3? Mode 3 is this direction, right? Okay? So you predict A by, you predict A, F, K, P. You predict these 4 pixels, okay? By this formula. A plus 2Q plus I plus 2 divide, do you know what this means? Shift by 2 means divide by 4 and then truncate, whatever, below the decimal points, okay? So what is A? A is this guy, 2Q. Q is this guy, I is this guy, okay? So you predict this edge, diagonal edge, by averaging A, I, and 2Q. Does that make sense? Right? That's a very nice diagonal edge prediction. Okay? And then if you pick mode 0, it will be different. Okay? If you pick mode 0, which is predicting that way, so then I guess MJGD will be predicted by the L and the M down here. Okay? And that's the way they do it. Okay? And after the prediction, the difference between the predicted values and the prediction and the real values will be encoded. Okay? So they say bit rates that way. This is for intra-blocks, right? Intra-block coding without motion. Now, 4x4 intra-prediction mode, which is that, has these features, okay? And then the prediction in the larger blocks, okay, is done this way. Again, it has 4 modes that allows you to do intra-prediction for larger blocks, okay? Then, innovation number 3 is flexible block motion compensation. This is probably the main reason why HR-264 is doing so well. It has many different, basically 7 motion modes. 0, 1, 2, 3, 4, 5, 6. Okay? These are different block modes. And it does exhaustive search for all these modes. For all the modes, they do entire, full search, motion estimation. Compute the SAD. Keep it. Move to block 2. Do motion estimations. Compute the SAD. Keep it. Mode 3. Okay, and then after the end, it checks to see who wins. Okay? The guy who wins got picked. Okay? The mode index is sent to the decoder, the motion vector is sent to the decoder, the residue is sent to the decoder. Okay? So it's a brute force algorithm checking everywhere and predict everything. Okay? And that's why it's so slow, but its performance is so high. Okay? An example would be something like this, right? You have a tennis player, and the racket is obviously moving very fast. Okay? And so if this happens to be your micro block, and the object is moving fast, you will never be. So this is the background, right? Okay. This is the background, and this is the foreground. The foreground is the racket. The background is whatever it is behind. Okay, maybe the scoreboard or whatever. Okay, so this is the background. This is the foreground. This block happens to contain both background and foreground. There's no way that this block is moving together. You actually have to split it into. These are the 2 background blocks. These are the 2 foreground blocks. And in this foreground block, maybe this is actually a background. This doesn't move. Well, it actually moves, but it doesn't seem to move. The racket is moving, but then all the strings look roughly the same. So it looks like a background, okay? So this is, turns out not moving, this is not moving, this is not moving, but all these guys, these three might be moving, okay? And that's how they do much better motion estimation, motion compensation, comparing to, say, MPEG-1, which is just doing motion estimation on this guy alone, okay? And that's one of the main features. Innovation number 4, multiple reference frames. Another brute force, ad hoc, but very effective technique. You search over 5 reference frames, okay, exhaustively. Well, you can. You can. The standard doesn't force you to do so. You can just choose one, okay, and be standard compliant. However, if you want higher performance, you actually have to choose this mode, okay, being able to search within the last 5 reference frames and find out the best match, the lowest residue. How do they do that? Search frame 1, search frame 2, search frame 3, search frame 4, search frame 5. For each of the frames, search all modes. For each of the frames, you search all modes. And out of these 5 times 7 modes, 35 overall, you pick one winner. Okay? That one winner got sent to the decoder. So the way reference frame works is like this. As you can see, this block might come from this frame, this block might come from that one, this block might come from here, and it can do bi-direction as well. Okay, with multiple frames. So very powerful. Okay. Innovation number 5, deblocking filters. Okay. When you have micro block like this, and then you do motion estimation, motion compensation based on blockwise. And one of the problems is that when you concatenate these blocks together in the decoder, there's a mismatch. There's a blocking artifact. We see blocking artifacts yesterday, didn't we? When we do motion, when we do we do that? Right, just for image coding, but it's similar, right? You do every block get encoded independently, right? And then you concatenate them together into the frame, and if you don't do anything at the boundary, there's no warranty. There can be a mismatch. There can be a mismatch, right? The mismatch comes up very annoying, blocking artifacts, okay? So you have to smear out the mismatch, okay? You have to filter out the mismatch. But you know that the mismatch only exists at the boundary. It doesn't exist inside, okay? So you should not filter everything. If you filter everything, if you take a low-pass filters and you just pass it through the low-pass filter, you're throwing away your real edges as well. You don't want to do that, right? So you want to adaptively just take a look at the boundary and just work on the boundary alone, okay? So that's another innovations that we have from 8.2.6.4. And this is one of the demonstrations. Blocking artifacts pretty much everywhere here, okay? And with the loop filters or the blocking filters, you can see that all of these regions, which looks really bad before, turns out to be very nice and very smoothly. Okay. And this also helps in the encoding of the next frame, correct? The next frame coming in and get predicted from this one, not that. So then the motion vectors become, the motion prediction becomes much more efficient, okay? Because these edges actually can mess up your motion estimations. And finally, innovation number 6 is context adaptive binary arithmetic coding. So the arithmetic coder being used in 2.6.4 is binary. It only understands 0 and 1. Only understands 0 and 1. Okay? But it context adaptive, meaning it actually takes a look at the neighbors, okay, and form a super symbol. Okay? And so we talked about that before.